We're going to look at another strategy for dividing fractions by fractions, and this is something that starts in 6th grade, but students work arithmetically with fractions, including division, for a long time after 6th grade as they're applying it to other areas. When students learn to divide fractions, typically most sequences in textbooks and in most districts, they will have already learned how to multiply fractions and may have already learned sort of an algorithmic process of multiplying fractions where you just multiply across. In fact, in the standards, multiplication of fractions by fractions happens in 5th grade, and then division of fractions by fractions happens in 6th grade. So this is background knowledge and understanding that students already have. However, when we teach division of fractions, one of the things that is often said right at the beginning is, when we add and subtract fractions, we find a common denominator, and then we can just add or subtract the numerators. And addition and subtraction have a similar relationship to multiplication and division. However, though with multiplication of fractions we divide it across, with division of fractions we can't divide across. We have to do it other ways. And that isn't necessarily the whole truth. We actually can divide across to divide fractions and get correct quotients. And so in this video, I'm going to talk a little bit about that strategy. I have some examples to show you dividing across with, how it works, why it works, and then also why we don't necessarily always teach that. So the first thing is I do not tell my students or students I'm working with that we can't divide across, because we can divide across. So we'll take this first one, 10 ninths divided by 2/3. So 10 ninths divided by 2/3. If I divide across, much like I would multiply across if this were multiplication, 10 divided by 2 is 5, and 9 divided by 3 is 3. So 10 ninths divided by 2/3 is 5/3. And if you don't trust that that's the quotient, I challenge you, pause the video, check that any way that you would like, use any strategy you would like, maybe a strategy from other videos where we've talked about dividing fractions or one that you have, but 10 ninths divided by 2/3 is 5/3. 9/16 divided by 3/8. So 9/16 divided by 3/8. If I divide across, 9 divided by 3 is 3, and 16 divided by 8 is 2. So 9/16 divided by 3/8 is 3/2, 3/2. Again, if you would like to pause, check it, make sure it works, but I assure you 9/16 divided by 3/8 is 3/2. So we've got one more example here, and maybe you're already seeing where this is going, but we'll go ahead and try it with this as well. 2/3 divided by 3/4. Now, 2/3 divided by 3/4, to divide across, this is going to look a little interesting. 2 divided by 3. It's not a whole number, but I do know that I can think of division as a fraction, so I'm just going to write, instead of a decimal or something like that, I'm just going to say that 2 divided by 3 is 2/3. And 3 divided by 4, same thing. That doesn't work out to be a whole number, but I'm just going to say 3/4. So we have 2/3 over 3/4. We have a complex fraction. And complex fractions aren't something that aren't explicitly taught until later. But I also think it's okay for students to see something like this and to think like, oh, well, a fraction over a fraction, what does that mean? And we certainly don't want to leave it this way. We want to find an equivalent fraction that's more friendly, and that's also something that I'm not going to teach students in 6th grade, is how to make a complex fraction not a complex fraction. So this didn't work very well. It's equivalent to any other quotient that might have a whole number numerator and a whole number denominator, but we're not going to leave it like this, and we don't want a quotient like this in 6th grade. Now, something that I do know about fractions is that anytime I have a denominator of 1, if my denominator were 1, then whatever's in my numerator, like something over 1, is just that numerator. 5 over 1 is just 5, 12 over 1 is just 12. So even if I had a fraction in the numerator If my denominator was 1, then I would kind of be okay. And so here's how we can make that happen. I know that to get 1 in dividing, because we're dividing across, I would need to divide something by itself, which is just having a common denominator. So if my denominators were both 12, because that's going to be the common denominator here, then when I divided whatever I had in the numerator, my denominator is going to be 1, and then so my quotient would be just whatever I have in the numerator. So let's write some equivalent fractions for 2/3 and 3/4 with denominators of 12. So we're going to have 8/12 and 9/12. So now we're going to think 8/12 divided by 9/12, we just divide across. 8 divided by 9 is just 8 over 9. And then 12 divided by 12 is 1. 8/9 over 1. Again, that denominator, we just have 8 over 9. So, yes, this is a little confusing, and this might be why we say, and have said for so long, that, oh, with dividing fractions, you can't divide across. But actually you can. Sometimes it's just a little bit more complex. But like in some of the other strategy videos for dividing with fractions, having a common denominator actually makes it a lot easier to think about these situations, expressions, even where it is a little bit more complex. So dividing fractions, just like with multiplication, we can divide across. Dividing fractions, we can also divide with common denominators. So where for I think a long time division of fractions has seemed like, or has been taught like, it is very different from addition and subtraction and multiplication, we actually see that it pulls a lot from the same ideas and the same reasoning that we use when we add, subtract, and multiply. All that can be applied to dividing fractions as well, if we've built that understanding and reasoning of what division of fraction means.